Let's talk about now about what happens if you react an acid with a salt. Okay, so what generally will happen is that the H plus from the acid will combine with the anion, the negative ion from the salt, to give you another acid. Now, you say that there's going to be a significant reaction only if the resulting product acid is a weak acid. So if the product, so this acid I have here refers to the product. If the product acid is not weak, then you say there's essentially no reaction with the H plus. Okay, so let's take a look at these examples here and write them ionic equations for these. Let's say sodium bicarbonate plus acetic acid, NaHCO3 solid, plus HC2H3O2, aqueous, yields. Okay, you have H plus from the acetic acid. It combines with the negative ion from your salt, so that gives you H2CO3. And that leaves behind sodium and acetate to combine to give you Na. Sodium acetate, sodium is plus 1, acetate is negative 1, so sodium acetate is NaC2H3O2. Okay, so that is your molecular equation. So H2CO3 would be in aqueous solution, carbonic acid, and sodium acetate would be in aqueous solution. Now, you may replace H2CO3 aqueous with CO2 gas plus H2O liquid. That's typically what you'll observe, okay? It decomposes further into CO2 gas and liquid water, okay? And that's this is in fact what you'll observe when you mix sodium bicarbonate, which is baking soda, with acetic acid, which is the acid that you'll find in vinegar. Okay, so that's your molecular equation. What would be our ionic equation? Well, okay, baking soda. Sodium bicarbonate, you say, that's ionic. Should I split that? Well, if it's an aqueous solution, yes. But in this particular case, it's a solid. You're using baking soda, which is a solid. So it has to remain intact, as is. NaHCO3 solid. And let me just leave out the labels now. Plus acetic acid, that's a weak electrolyte. A weak acid, so I have to write it intact as HC2H3O2, aqueous. Gives me CO2 gas plus H2O liquid. None of those are ionic. And then my sodium ion must be, sodium acetate is an ionic compound in aqueous solution, so I split that up into sodium ion plus acetate ion, C2H3O2 minus. This whole thing is your ionic equation. It's also your net ionic equation, because you can see there are no spectator ions that you can cancel. Okay, let's look at HNO3 plus K2S. Oops, sorry. HNO3 aqueous plus potassium sulfide aqueous. Okay, so the H plus from the acid combines with the negative ion from the salt, gives you H2S. Why H2S? Sulfide's negative 2, H plus is plus 1, so that gives you 2 H's for every S. And this is going to be aqueous, okay? And then the other compound that you make, potassium and nitrate, potassium is plus 1, nitrate's negative 1, so it's just KNO3 aqueous. And to balance this, you're going to need 2 H pluses for the S, so I have to put a 2 there to get it balanced. And another 2 here to balance my potassium and my nitrate. So this is my molecular equation. Okay, depending on how much H2S you're making, typically, actually, you'll observe this as H2S gas. Okay, you can smell it. This will give you the odor of rotten eggs. Okay, if you did this experiment in the lab, you'll be able to smell H2S gas. So, H2S has a limited solubility in water. Okay, so what would be the ionic equation for this? You're going to say HNO3 is a strong acid. It's in aqueous solution, so I have to split it up into H plus and nitrate. Since I have a coefficient of 2 there, I have to put the 2 for both H plus and nitrate. Potassium sulfide, again, ionic compound in aqueous solution, so I have to write that as 2K plus sulfide. There's only one sulfide, right? Note, I don't write it as K2 plus, okay? K2S means you have two potassiums and a sulfide, so 2K plus. There is no polyatomic ion in the symbol of K2. And then my product would be H2S plus, this is 2 potassium. Potassium nitrate, again, is soluble in water, so 2 potassiums plus 2 nitrates. That's an ionic compound in water, so I have to split it up into 2. This would be my ionic equation. And to get my net ionic equation, I leave that up to you to finish. You just have to get rid of your spectator ions, which are in this case nitrate and potassium. Okay, so what happens here is your 2H plus from the nitric acid combines with sulfide from potassium sulfide to give you H2S. And finally, that last example, let's say the third example here. Sulfuric acid plus magnesium sulfide. Let's see what happens there. H2SO4. I should split that. Okay, let me just write the full molecular equation. H2SO4 aqueous plus magnesium sulfide, MgSO3 aqueous. Okay, the H plus will combine with the sulfide. That gives you H2SO3, which is a weak acid. Okay, and magnesium sulfate. So H plus and sulfide, you're gonna need 2 of sulfide is -2, H plus is +1, so you need 2 of the hydrogens to form sulfurous acid. And then magnesium sulfate, Mg is +2, sulfate is -2, so magnesium sulfate is MgSO4. And that's aqueous. And then to balance it, I'm going to need, nope, that's already balanced. So this is your balanced molecular equation. Okay? And this one also, you may write this as, instead as H2O liquid plus SO2 gas. Okay, because sulfurous acid, if you have a high enough concentration of it, you'll be able to see it bubble out and give you a sharp smelling gas, SO2 gas. Okay, so you may replace H2SO3 with H2O liquid and SO2 gas. Now, let's write the ionic equation. You have sulfuric acid, strong acid, so I write it separately, 2H plus and a sulfate ion. Magnesium sulfide is an ionic compound in aqueous solution, so I separate them as Mg plus 2 and sulfide, which is -2. My product, H2SO3, or I can write it as H2O liquid plus SO2 gas. Those are molecular compounds. Write them as is. And magnesium sulfate, that's an ionic compound in aqueous solution, so Mg plus 2 sulfate ion. Okay, it's an aqueous solution because I know from my solubility rules that that's not going to be insoluble. That's not going to be a precipitate. So this is my ionic equation. And to get rid of my spectator ions, I just have to get rid of my magnesium ions and my sulfate ions, and that would give you your net ionic equation. Okay, so just get rid of the magnesium and the sulfate, and you got yourself your net ionic equation. Finally, let's look at the last one, HCl plus barium sulfate. HCl, aqueous, plus barium sulfate solid gives you barium sulfate. Oops, this should be solid. Okay. Barium sulfate will not dissolve in water. It's insoluble in water, so you can't have that reaction with aqueous solution of barium sulfate. So let's just say barium sulfate solid. So what could happen here? Well, let's see. H plus and sulfate will give you H2SO4. That's another strong acid, so that's not going to happen to a certain extent, to a significant extent. You would have gotten H2SO4 and barium chloride, right? But since H2SO4 is also a strong acid, then this reaction is not going to occur to a significant extent. So you would say no reaction expected here, no significant reaction. Okay?